This is part 2, and in this video I will be talking about the different types of data, and I will give examples so that we are all on the same page. So yeah, the first type of data is known as qualitative data. This is the type of data that can be observed but not measured. So you can collect this data, you can observe, but you cannot really measure it. Qualitative data. Now there are two types, also other subcategories of qualitative data. The first one is nominal. Nominal data is data that does not have a natural ordering, like there's no order. It's just qualitative data that you can understand and get meaning of, but there's no natural ordering. A good example is color. You cannot say red is greater than blue or green comes before yellow. There's no ordering, but each color represents something and has a meaning behind it. So that is a good example of nominal data. Another good example of nominal data is gender. You cannot say male comes before female. You're either male or female. There's none of them is greater, none of them comes before the other. So this is a good example of nominal data, color and gender. Now the second subcategory of qualitative data is known as ordinal. Ordinal data actually has a natural ordering. So there's an order that it follows. A good example is the size of clothing. When you go shopping, you'll find different outfits, and even if it's the same type of dress, there will be a small, a medium, a large, and extra large, so there is some order. So that is a good example of ordinal data. Another good example of ordinal data is the grading system in schools. For example, we all know the alphabet A, B, C, D, E, but then in the exams that we do when they're grading us, you know that getting an A is better than a B, and a B is better than a C. So it has a different meaning because now it actually follows a natural order. Another example of ordinal data could be an opinion, or like an opinion poll. Maybe I launched a poll and I asked you, how are you feeling about our services? And I gave you the option of saying happy, extremely happy, not happy, extremely sad, or like it's an opinion, but I can grade it based on something that's less or more. That's another example of ordinal data. So qualitative data is the main category, and this is data that can be collected and observed but not measured. And then the subcategories that fall under qualitative data is your nominal data and your ordinal data. And like I said, nominal data is qualitative data that does not follow a natural order. So like color, gender, while ordinal data follows an actual order. So things like the size of clothing, the exam grading system, or even like an opinion, something goes from great to greater or worse. So there's a scale, and that's the first type of data. The second type of data is quantitative data. I'm sure by now you've guessed this. This is the type of data that can be counted and measured. Why can it be counted and measured? This is because it has been assigned a numerical value. There's a number or a numerical value assigned to this information. Now, just like in the earlier type of data, this one also has two subcategories. The first one is discrete. Now, discrete is quantitative data that has numerical value, but this numerical value is whole. Let me give an example, like age. You cannot be between 16 to 18. As an individual, you know your exact age is, let's say, 20. You know you are 20. You know you're 25. You know you're 18. That's an exact number, a whole number. So that's considered discrete data. Another example is weight. You know you are 60 kgs, you are 50 kgs. It's an exact exact number. Or let's say you have a phone, and this phone is dual SIM, which means it can operate with 2 SIM cards. That's an exact number. So this is a good example of discrete data. Now, the second subcategory of quantitative data is known as continuous. So this is data that has a numerical value, and this numerical value is fractional or continuous. For example, temperature. So it's either going to go from a certain number of centigrades or Fahrenheit. Another example would be, like, let's say with the same phone, even though it's an Android, it falls within a certain series. Maybe it's an S1, S2, S9, or iPhone 10, iPhone 11. So that's fractional because it's continuing. It's continuous. So that type of data is known as continuous. So I'm going to repeat this. There are 2 types of data: qualitative and quantitative. Qualitative is data that can be collected and observed, but it cannot be measured. And within qualitative data, we have 2 subcategories. We have nominal and we have ordinal. Nominal has no natural ordering. This is data such as color or gender, while ordinal follows a certain order, like it has a natural ordering. And the good example of ordinal data is, like I say, the size of clothing. You go from small, medium, large, extra large, or also the grading system in schools, where getting an A is better than a B. And the second type of data is quantitative data. This is data that can be calculated or measured, and this is because this data has been assigned numerical value, which means you can count it, you can measure it. Now, within quantitative data, we also have 2 subcategories. We have discrete and we have continuous. And discrete, like I explained, is data with numerical value, but this value is whole. So like your age, your weight, it's an exact figure. While with continuous, it's fractional, or rather it continues, like it's a range. So like things like temperature, or even like, let's say, what example did I give earlier? Yeah, versions of the phone. You have an S9, someone else has an S10 or an iPhone 11, like it's continuous, but it's within the same type of phone. So those are the different types of data. I hope I was very clear in the explanations. If not, send in your questions, your comments. Continue engaging with me. In the next video that I will share, I will be talking about the pros and cons of data, as well as the different characteristics of data that we should all be keeping in mind before making strategic decisions.